for example, we're going to have an integral like this. Integral of x squared minus x times x plus 3. It's an indefinite integral. So again, for us to be able to do these problems, we need to write it in terms of powers of x only. Sums or differences of powers of x. So we would start here by rewriting this. So multiply out x squared times x is x cubed. That'll give us a 3x squared. But then we'll have in the middle there a minus x squared. So we'll have really plus 2x squared. Because we'll have 3x squared, and then in the middle a minus x squared will leave us with 2x squared. And then minus x times 3 be minus 3x. And then we just apply the power rule for each part. Now if you find it helpful, you may want to break this up into separate problems. And then apply your power rule for each part. So in each case, we add 1 to the exponent and then divide by it. So for integral of x cubed, we would say add 1 to it, then divide by it. For x squared, we'd add 1 to it, and divide by it. Integral of x, we'd add 1 to it, and then divide by it. And don't forget though, it's an indefinite integral, so we have to add on that plus c. Yeah, with the definite integral we don't need plus c because we're going to end up plugging numbers in anyway, and the c's would really just end up disappearing. And just clean that up so it looks a little bit nicer. That would be 1/4 x to the 4th plus 2/3 x cubed minus 3/2 x squared plus c. So here we have now a definite integral, 6x cubed minus 8x squared dx. Again, you can, if it helps you stay more comfortable when you're doing these, you can break that apart and just do each piece. So here we're doing integral of x cubed. So we'd add 1 to the exponent, divide by it. Here we're doing integral of x squared. So we'd add 1 to the exponent, and then divide by it. And now it's a definite integral, so we're going to then evaluate it at our two endpoints, at 1 and at 5. So 6 and 4 would simplify to be 3/2. So, 3/2 x to the 4th. And that would be 8/3 x cubed, again evaluated at 5 and at 1. So we just start to work that out. Plug in 5. So it would be 3/2 times 5 to the 4th minus 8/3 times 5 to the 3rd, and then minus, and we plug in 1. 3/2 times 1 to the 4th minus 8/3 times 1 to the 3rd. And at this point, you're perfectly fine coming up with a decimal answer here. I'm not going to torture you with having to go through and add up all those fractions and subtract them and so on. Okay, so value when you get 605.33. Example here with an integral. This being here in this case an indefinite integral. And that's just to really review and refresh what you know about your power rule. Okay. So again, when we do these problems, we want to express it as a power. So we would rewrite it first as x to the negative 1/3 dx. Right, cube root is 1/3. It's in the bottom, so it's negative 1/3. And then we can apply our rule for powers. Add 1 to the power, then divide by it, plus c, because it is again a definite integral, or an indefinite integral. And so we get the answer 3/2 x to the 2/3 plus a constant. And again, your tests on Friday. There'll be some questions dealing with the derivative of e to the x. A couple questions dealing with indefinite integrals. There'll be a question dealing with definite integrals. There will be a question dealing with the net change of a function. And then one question asking either about the consumer or producer surplus. And that example that we did just a few moments ago is really a good example of the kind of question you might be asked with either consumer or producer's surplus. Okay.